Hi, good afternoon, everyone. Welcome to another Ironside Take 30 with a data scientist. I'm Pam Oscar. I'm the Director of Data Science at Ironside. Today, we will be taking an industry focus and looking at AI applications in higher education. Ironside's industry agnostic. We work in a lot of different industries, but have a specific deep pocket of experience with higher ed. And so we'll be speaking about all of the work in AI that we see across that industry. So let's kick it off. I'd like to start by reminding our clients and ourselves about Ironside's mission statement, which is to help our clients use data to make better decisions about their business. And we do that with 20+ years of end-to-end data and analytics value. We have expertise across that entire lifespan of data and analytics, from advising, we'll be talking a little bit about that today, setting up a strategy and roadmap, designing, building, deploying, where you would expect data science to come in very heavily, but also governing and manage systems. So today's agenda, like I said, I'll focus around predictive analytics, AI in higher education. We're going to talk about where higher ed organizations are using it today, and then talk about where they might be using it in the future, and where some organizations are looking to apply it beyond just where they've gotten started. And I'll end up with talking about some new trends in around COVID-19 and how educational organizations are trying to use advanced analytics to tackle that and to better understand how to keep their students safe, how to keep their business up and running, etc. So I'm going to start by just giving you some examples of some success stories where AI has been used already. So Georgia Tech had this issue where their teaching assistants, and this is true across almost any large university, their teaching assistants were responsible for these very large introductory courses where there'd be over 300 students, and they would be dealing with over 10,000 messages from students in a given semester. Now, I can tell you from experience, going back to my grad school days, most of those messages had very similar answers, like it's in the syllabus, right? Or you can look it up. What should I cover? What chapters are covered for an exam, or what day is this exam, etc. And so, even though the number of messages was vast, the unique questions were not that vast. So there weren't that many distinct questions they were getting. So they took a creative approach to this. They used IBM's Watson, and they saw how it won Jeopardy, and they thought, well, if it can beat Jeopardy, I'm sure it can handle my students and their questions about, the syllabus and their exams. And so they trained a model and provided this robotic teaching assistant named Jill Watson. And they didn't tell the students that this wasn't a real person, but they would go on their platform and put in their questions, and they would see which TA would respond. And a lot of times it was Jill giving a response to them. And it was actually quite successful, using natural language processing to give them the appropriate answer and really mimic some human behaviors, at least in that interaction. Now, Jill couldn't really tutor students and help them more broadly with their coursework or their goals, but but she was able to unburden the real TAs, the human TAs, from doing that mundane Q&A back and forth, so that they could really provide the more quality direction that students needed. That's one example. Another very similar one from Arizona State created some chatbots. Not for a specific course, but across the university, just being able to answer students' questions. In this case, they did tell students that this was a chatbot, and it had a very positive effect, because students feel like they're not talking to a human, and so they can ask questions that they might be a little bit embarrassed or awkward asking a human. Even something like, what's FAFSA? So if they asked about their student loan application and the answer was something about FAFSA, they might be like, well, I don't know what that is. And they found that students were actually a little more open talking to the chatbots, and they could follow up like, I don't know what that is. Can you tell me more? So it had that positive impact there too. So these are a couple examples of big wins, success stories, but we see advanced analytics very commonly applied across a lot of organizations, specifically in 4 areas. So one is enrollment. I'd say if any higher ed organization is using predictive analytics today, it's probably for enrollment. It's a key problem, understanding and forecasting which students are actually going to enroll after they've been accepted, helping to manage and balance that. You can also build simulators off that so that you can look at the impact of different scenarios of financial aid packages, for example, on a student's likelihood to enroll. So that's probably the most common. We also see a lot of higher ed organizations looking at academics and proactively trying to address students who are at risk of not succeeding, right? The opposite. Who are the anomalies that look like they might fail or drop out anytime soon, so that you can take some proactive steps and reach out to them early. Another one is student affairs. Really, that's some of the examples I already talked about with the robotic teaching assistant and the chatbots, but being able to enable students to find answers, make them more self-sufficient, and allow the university resources to be optimized in better ways. And then the fourth is advancement. We see this a lot too, looking at personalized marketing around fundraising and donorship, and being able to identify top donors or alumni who are most likely to donate. So I would say these four areas are where we see higher ed organizations leveraging advanced analytics today. And I want to talk about a case study where we're really looking at moving beyond that and a lot of other opportunities for AI. So this was a data and analytics roadmap that Ironside delivered to Northeastern University just last year. I have a little bit of information there about Northeastern, but really I would say that they are leaders and at the forefront of data and analytics from an aspirational and strategic perspective. So they really are looking to be digital and global, and to provide that global experience. They're looking to acquire students for the lifelong learning, right? And so keep them long term. So when you go there for undergrad, you're more likely to go for a graduate program to take courses and know, as you're part of that community, that you can take courses later on in your career that can help advance your career, for example. And so even though I'd say they're leaders in that aspirational goal of being digital and being an analytics-driven organization, they were looking for a roadmap that gave them the actionable steps to take to get there, and that's what we were there to provide. Now, I'm not going to talk about this specifically a whole lot today, the data and analytics roadmap, because tomorrow we are actually presenting more on that. So the Take30 with a data advisor will be delivered by Paul Hardy, who worked on this engagement with me and led it. So he'll be talking about the process and the outcomes a little bit more broadly, and I think Debbie will actually put the link to that in the chat box. So if you haven't registered for tomorrow's session, you can pick up that link and register for that. But what I'm going to talk about is a specific piece of that project where the key goal was to uncover opportunities for AI across the organization. So as they're looking for ways to build a modern data platform, for example, get a single view of their customers, all these other things. They also want to know, where can we use AI across the whole organization, and can we start to build a roadmap for putting that into place? So that's more what I'll talk about. So this slide, again, I won't cover a whole lot because this is something Paul will go over. This is our approach to data and analytics roadmaps. But some of the things I wanted to call out, first of all, the interviews. We interviewed over 60 stakeholders across the university. It's a large university. We talked to people in enrollment and advancement, in lifelong learning, even like public safety, because campuses run like small cities. So we talked to a number of different people and identified nearly 200 use cases. Now, most of those are for the data and analytics roadmap, but about 30 of those were AI use cases, places where we identified they could use AI to solve some specific problems. Some of those turned into specific initiatives. The other thing to point out from this slide is that there are 175 data sources that we identified. So I think part of what happens in higher education organizations is people tend to be very siloed, and they have their data right here, and they look at their data and what they can do with it. And this allowed us to take this broader view of the entire organization and say, you don't just have this data to solve this problem, but there's data across the organization that we can bring in to leverage larger problems. And that's really the approach that we took. So you may have seen a similar slide, or I've talked about this approach in other Take30 sessions before, but our approach to use case development is top down and not bottom up. So if you start with the data that you have and you say, what problems can I solve with this data? You can often go off track and start putting work into solving a problem that nobody really needs solved. The alternative is this top-down approach where we say, what are your business goals? What's going to lead to that success? And we tailor our questions to go step by step down from that. Well, what are the business moments and the decisions and the actions that will get you to those goals? And then what do you need to know to make better decisions to get you to those goals? And then ultimately, what data do you have? Now you may have that data there, or we can bring that data in from other parts of the organization or from external. So this allows us to make sure that we're solving the right problems. And we look at essentially what data do we need, do you have it, and can we find it? Rana Glasgow was our sponsor on this project. She's the Associate Vice Provost for Institutional Research and Development at Northeastern. And she mentioned that this process brought out a creativity in how to use the data that she wouldn't have thought of before. And I think we really witnessed that across all the interviews, the excitement and the interest and creativity that people came up with when you stop thinking about, well, I have this amount of data. Let's think about the goals for the organization as a whole, the goals for your functional area, and then we'll figure out the data to get there. And that resulted in not just those 4 use cases that are very common across a lot of higher ed organizations, but a lot of very creative ideas. So we have enrollment, academics, I've talked about that. Facilities we haven't really talked about. And then I have others here because there were a lot of other random ideas from HR and other groups as well. So I'm not going to talk about all of these in detail, but I'm going to highlight just a couple that I thought were really interesting. So in enrollment, we talked about enrollment forecasting, how that's kind of standard at a lot of places. They're using predictive analytics to identify, to manage their enrollment. We also talked about a course level demand forecast. And so what we're talking about there is not just reacting to this course is really, really popular, maybe we need to offer more sessions, but bringing in external data from the job market, right? Where's the market going? Where's the demand going? Let's make sure that we're offering courses that meet the demand of our students, because in the end, this is a business and students are customers, and you want to make sure that you're offering products and services that are in demand by your customers. Even 5 years ago, I'm not sure there were data science classes or programs offered at most universities, for example. And so, looking at the job market, and data science is still one of the most in-demand jobs, you could see an organization bringing that in and adding that to their enrollment and course level demand modeling to get a better forecast of what's going to be in demand tomorrow and next semester ultimately. The other idea I wanted to talk about is taking that predicting at-risk students to another level by bringing in behavioral information. So not just academic information to tell you about which students are failing, because at that point they're already showing failures and success. And so you can see their grades are deteriorating. That's obviously going to be a strong predictor of them failing or dropping out. But we talked about students that might actually be doing fine academically, but then drop out or withdrawal. Maybe there's social patterns there that they're not fitting in and not doing well. So it could lead to predicting students socially not acclimating or academically failing, but maybe possibly getting to them a little bit sooner. Most universities now have swipe data and a lot of digital data about students buying tickets to sporting events or checking into the library, checking into meal halls. And so you could, in theory, leverage that information to really get some early alerts that a student is showing patterns of behavior that in the past have been associated with them suddenly withdrawing or starting to deteriorate in their academics a little bit earlier than just the traditional academic at-risk models. This is one I wanted to bring up because I don't think people often think about this with higher education. But a university or a college is often run, at least a physical campus, like a small city, as I mentioned. And so you have a lot of equipment, you have a lot of facility costs and burden to deal with, like any small city would. And so Predictive maintenance is a very common analytic approach in manufacturing that could also be brought into higher ed and campuses. So the idea is to reduce the cost of reactive repairs by managing proactively, by getting some alerts and identifying predictive maintenance that you can prevent. And we've already kind of talked about the donor models and also top donor propensity loyalty programs, which I'll talk about in just a moment. So a lot of opportunities under advancement and alumni. And this last one's also really interesting, course market basket analysis. So if you're familiar with market basket, that's the idea of looking at what things tend to co-occur in someone's basket, right? The classic example is diapers and beer, right? They discovered that those two things are purchased together very often. At least this was, I don't know, maybe 20 years ago. People stop on their way home from work and pick up some diapers and some beer. That's the classic example, but market basket type analyses are done in other ways. So one thing that was discussed is to look at ways to restructure programs or unbundle coursework by looking at courses that naturally kind of co-occur. So there were examples of courses in one program that were often taken by students in another program, just because the interests aligned, and that wasn't really obvious to someone just from one program or the other. And so if you can understand how students are structuring a coursework together by their interests, by their program, by potential job opportunities, that helps you to better understand how to build your products and services that you can deliver. So it has a lot of examples. The other key component of the data and analytics roadmap that we delivered for Northeastern was to do a pilot. And another quote here from Ronish said, one of the things we insisted on was demonstrating value. So not just delivering a roadmap and here's some steps, but let's see how this would actually work here with our data, with this process. And so she said that the pilot provided real insight about the process and about our data. So the use case that we selected out of all of those was to look at re-enrollment into graduate programs. So one of the things I mentioned about Northeastern is that they really promote lifelong learning and being a part of the community for the long term. And so they have discounting programs for undergraduates who would enroll in graduate programs, and really wanted to understand the effectiveness of that and understand who are the types of students that take advantage of it. And so can we market specifically to them, or can we make it more well-known among other programs, for example? And so we delivered a model that with a propensity to re-enroll and take advantage of this discount so that they could understand that. And what you're seeing here is just a mock-up of a dashboard that we provided with that, so that it's not just a propensity score for each student, but really some analytics that were surfaced, some insights that were surfaced through the model itself. And one of the things I thought that this highlighted is that universities, colleges, all higher ed organizations have very similar problems and goals and use cases. So all of those that we've talked about, especially those first four, we can see being applicable across all higher ed organizations. However, each organization is very unique, and so you could see that something like this model here in this use case doesn't really apply to maybe a turnkey off-the-shelf solution built for student enrollment predictions, right? Every university I've worked with really has their own special sauce and unique programs and unique approach to things, and so it's important to keep that in mind and think about the uniqueness of that and customizing a model for just your organization. So from here, I wanted to turn to a different topic, which is really everything we've talked about is pretty standard. Now we kind of live in a new world, and we have to deal with COVID-19, and any educational organization right now is kind of scrambling to figure out what to do for fall, how to keep their students safe, their employees safe, how to keep their business running. And so there are some new ways that new creative solutions to using advanced analytics to really understand the impact of COVID-19 on their business. And I just want to talk about a couple of these. Cornell has published a study that they just did. It didn't go through peer review. That takes a very long time. They put it out there in open source because, again, this is kind of an urgent matter. But they put out there this very interesting study that they did that used network analysis to understand the degrees of separation that students on campus would have. So traditional network analysis is done with social networking. And there's the famous theory of 6 degrees of separation, saying that we are all connected by just 6 degrees. So I know someone who knows someone who knows someone who knows someone who knows Elon Musk, for example. And so we're all connected that way through only 6 steps. So the researchers at Cornell use that same analytic approach to looking at their students and how connected are 2 people if one is infected, right? And to help you better understand the potential spread. They found that there's actually only 2 degrees of separation existing between students, even in scenarios where you put those large introductory courses online. One of the quotes they had was that the average student can reach only about 4% of other students by virtue of sharing a course, but 87% of students can reach each other in 2 steps. That's pretty huge. So I might take a class with someone who is then infected and shares a dorm room, for example. And at 3 steps, it's 98%. Now, again, this was not peer reviewed, and it's really the first study of its kind. They said that it really, 2 students take a class, they may not actually become physically close enough to each other to contract COVID-19, and so it might overemphasize this impact. However, this really only looked at taking courses together. It didn't look at all the other ways that students on a campus interact with each other through friends, dining halls, advisors, dorms, clubs, etc. And so, so I think it's an early study, but it's a really unique and creative solution to trying to understand how your students are going to interact with each other and what steps you might need to do to keep them safe as they come back this fall. Another thing we're seeing is e-learning effectiveness. It's another really important use case of trying to understand time spent on learning solutions and the impact on student outcomes. I can tell you it does not work with 4-year-olds, but I think it could probably be more effective with college students. Some of the important things that these studies are looking at, though, is discrepancies between student groups. So low-income students and their access to computers and internet. Non-traditional students who may be home with families and, trying to learn online might be very different than when they could go to a campus and learn in a classroom. And also international students who may opt to stay home, but if they're trying to take a course that is synchronous and they're trying to take it at home, they have to stay up till 3 a.m. to take their course. How does that impact them? And so advanced analytics are being used to really better understand the discrepancies between student groups and really understand the best way to make e-learning as effective as possible. And the last one is space demand forecasting. So all of those enrollment models, and if they already have space demand models in place, have to be thought about very carefully now, because your machine learning algorithms are using historical data, and COVID-19 has never happened historically. So your model's just like an ostrich with its head in the sand, knowing nothing about COVID-19, and it's just happily going to give you predictions for fall enrollment as if nothing has happened. And so a lot of people are going to need to be doing some manual overrides and simulating different scenarios for fall to get a better sense of enrollment. But what that does is also create a cascade down to space demand. So understanding actual enrollment, actual in-person enrollment, and then adding to that the need for social distancing and spacing out dorms, for example, making them less dense, or classrooms, etc. So there's analytics being applied there as well. So I think these new trends are going to continue and become even more creative in people's solutions to using analytics to help them understand COVID-19 and the impact on them. So that's really all I have, just some key takeaways here. Higher ed organizations are already taking advantage of AI. I mentioned 4 areas where I think a lot of places are already finding a lot of success with AI and other advanced analytics. And like any business, there are opportunities for AI across all the different functional areas. So we talked about like facilities. One that I had on there but didn't mention was HR, looking at faculty churn, for example. Higher ed organizations face very similar challenges, and so the use cases really seem to be kind of plug and play and applicable to a lot of them. However, your unique data and your unique twists on them don't fit across organizations. Everybody is kind of unique, and it makes those turnkey off-the-shelf solutions a little bit more tricky to plug in. And last, there's a lot of new opportunities arising due to COVID-19 that advanced analytics are being used to tackle, and a lot of very creative people are thinking up some creative solutions. So be watching for some more of those. So that's all I have for you today. I just wanted to leave the rest of the time for some questions. You can either type them in the chat box, or I think Debbie will allow you to take yourself off mute if you want to just speak up and ask any questions that you have.
We have two of them that have come in. One of them is, what is a cost-benefit analysis done, or was a cost-benefit analysis done on any of these endeavors? And sort of what format would they look like?
That's a really good question, and that is part of these data and analytics projects that we do. Paul will probably talk about that a bit tomorrow, because I'm often looking for use cases and then identifying what data would need to support them. Paul and I work really well together on a lot of these engagements where he's looking at the business side and the business value and quantifying that, and then we do that cost benefit analysis. So it would look very different for every single use case. Often, and I think we talked about this in one of our prior sessions where Paul and I presented together, we do a 2x2 matrix where we're actually plotting data value against business value, so that you can understand what are your high value and feasible use cases to tackle, what are some that require some data remediation that they're very valuable, but you don't have the data, or you don't have the right data governance, for example, so you can put that into place. So that's typically what we do and how we present these in mass form.
Thanks. And another question we had was on machine learning, and if we were using regression-driven solutions, or if we were putting them in and utilizing it within machine learning.
So I think it partially depends on your definition of machine learning. A lot of times I think machine learning methodology is pretty broad, and you can even include regression as one of the algorithms or one of the methods to solve those problems. Other people talk about machine learning once you go into that recurrent auto learning, where you build a model, you train it, you deploy it, and then you set up some systems so that it's taking the outcome and refeeding it, which is always a good idea to do once you get into deployment, right, where it's relearning after itself. And so again, it depends on the use case. It depends on once you finally get it into deployment, and so you set up that recurrent learning system. Big data, I don't put too much stock into whether there's big data or not big data, because I think people are surprised at how much you can do with maybe quote small data, or that you don't need terabytes of data to get a lot of value here. So even though it may not be a regression, I may still use very novel and newer machine learning algorithms with smaller data sets. You can certainly do that. I mean, unless you're talking about like deep learning. I hope that answered that question.
Yeah, that's terrific, Pam. One last question. I know you have done previous sessions on data enrichment. Have you utilized data enrichment in any of the higher ed use cases?
Yeah, data enrichment is great in a few ways. One is enrollment and understanding your student body, who you're marketing to, who's applying, and who you're giving offers to, and you know, understand where they come from and kind of the families and demographics, so that you can better understand their propensity to enroll. Also, donor models, it's really great to get that demographic information, socio-demographic information, specifically location data, to help understand propensity to offer fundraising and large donor gifts. So I'd say that's two that are very common.
Terrific. I think we're about.
I think about location intelligence. Yeah, the last thing I was just going to say is about property attributes might help with facilities, right? Understand the buildings that you have and their attributes. So looking at predictive maintenance, that might be another one. But yeah, so we're out of time. I thank you all so much for joining today. And again, I'd encourage you to join tomorrow to hear more about the data and analytics roadmap for higher ed. Thank you very much.